what I want to do is to look at the Cohen article and work through his examples. Not all of them, but just 3 of them, maybe 4 of them. And then we'll use G-Power to do the same examples. And then by that point you'll know as much as I know about power and G-Power, and then you'll be able to do these other problems, both with the Cohen article and with G-Power. You have to do the plan for whatever class time is remaining, or for the beginning of the class starting next week, okay? And then the first homework, which isn't we don't have class next Monday, right?
Right.
And so whatever the first homework is it the next Monday then? Or is it, I think it's next Monday. There will be probably a couple problems on there that will be use G-Power to calculate the power for these couple problems, okay? And so and then it could be a reoccurring homework or take-home exam or not in class exam.
You had said those assignments would be the Friday of the week that I proposed it.
That's correct. So you'll get it Monday, and you'll have to, but you'll have to get busy with them and have them done by Friday, so you can get them uploaded to D2L. I say Friday, but if you upload it at 4 a.m. on Saturday morning, I'm not going to care. I'll only care if I can't get to it when I want to start grading them on Saturday morning. So I'll grade them Saturday and Sunday, and I'll be able to turn them back to you on Monday, and we'll be able to talk about it. And it just works a lot better than you giving them to me on Monday and then me turning them back to you a week later. Yeah, for me it works a little bit better too because I can get them graded.
We have a homework assignment the week of the fall holiday, so I just wanted to make sure.
The fall holiday is the
Don't
Texas.
make it due on that Friday. Yeah.
The Texas, yeah. So we can
Don't
make
make
it.
it due on Thursday. That's what I'm saying.
You'd rather have it due on Thursday? Is that what you're saying?
No.
Will you remind me of that? And so we have Friday off. Well, you have Friday off. I'll work Friday. And then we have class the next Monday, right? So will remind me, and we'll change the due date to Monday, so you'll bring it to me. Sorry, that's not much better than Friday, is it?
Monday?
Yeah. Actually, it's
I
worse.
just didn't want you to move it earlier, so.
Right, so
It
it'll
can
be
be whenever.
Monday. What's the homework?
Number 4.
I mean,
And I just said before, what's the topic?
it's number 4.
We'll work it out. I'm flexible, and I wouldn't want a homework due on the day that we don't have classes anyway. I just wouldn't do it, so we'll work something out. And I won't make it earlier.
The week after we don't have, it's our catch-up week, so.
What's that?
The week after.
Is the
we don't
catch-up
have
week?
the catch-up week,
Ah,
so
yeah.
there's no homework
Celebrate.
assignment.
We're good. So yeah, we'll work something out. I might revise the schedule if I think about it and change it to that Friday of that week, or I might just wait till I do the assignment. Either way, we'll make sure that happens. All right? So Cohen, and we're going to. Everybody should have the article, hopefully either digitally or otherwise. And we really want to focus on table 1 and table 2. And so table 1 is the metric that we use to calculate the effect size. And then table 2, we take that effect size and we find out we determine what alpha level we want, and then we calculate the sample size that is needed for our study. Okay? So we start with table 1, get the effect size, and then go to table 2, input the data into table 2, and come up with an estimate of sample size. It works really good and it matches G-Power exactly, as long as we're on exactly small, exactly medium, or exactly large effect sizes. When we get in the middle between small and medium, is where we tend to have, well, there will be differences. And so that's where G-power would definitely be a better way to do it. So if we look at the first example, or the first test on table 1, it's where we have 2 means, so it'd be a t-test. 2 independent means. What does independent means mean as opposed to dependent means? Independent means, Cameron, are?
It's not a paired sample t-test, it's an independent sample.
Yeah, they're not time 1, time 2, so it's 2 different groups of people.
Yeah.
A dependent t-test or dependent means would be means where we have the same people for mean 1 and mean 2. We just are doing time 1 and time 2, or before and after, whatever. But this is independent, so 2 different groups. Very important difference, and a mistake that you wouldn't want to make. And to calculate the effect size, which is D, it's mean for group A minus mean for group B divided by the standard deviation. And that would be the pooled standard deviation, or the standard deviation of all groups, not the standard deviation for A or B, but the standard deviation for A and B combined. And in theory, the standard deviation for A and B, would it be exactly the same? No, but in one of the assumptions is that the standard deviations aren't significantly different, which we'll talk about when we talk about ANOVA. So we can calculate D by taking mean for group 1 minus mean for group 2 divided by the pooled standard deviation. And if the number is somewhere around 0.2, call it small, 0.5 is medium, and 0.8 is large. Okay. And so then what we would do is go to table 2. Hopefully this isn't too elementary. Table 2 and test number 1, mean differences. If we want our alpha to be 0.05, we're going to use the middle 3 columns. And if we have a small effect size, medium effect size, a large effect size, we'd need 393, 64, or 26 participants per group, respectively. And that's per group. And I know that it's per group because page, the previous page before table 1, I don't have that, 156, I guess. Under sample size, you should underline and put an asterisk there. For statistical tests involving 2 or more groups, N, as here defined, is the necessary sample size for each group, okay? So the 393, is that what it was? 393, 64, and 26 were the per group sample size. Good so far? So we haven't even worked the problem yet. So the first problem we'll look at is under his examples on that same page as table 2. Example 1 uses independent sample means. He says to detect a medium difference between 2 independent sample means, D is equal to 0.5 in table 1, alpha is equal to 0.5, N equals 64 in each group, right? Does that make sense? Good enough? Any questions about independent mean differences? And we can do the same thing with G-power, but just more precise. Because maybe we won't, when we calculate mean 1 minus mean 2 divided by the standard deviation, it might not be 0.2, 0.5, or 0.8. It might be, what if it's 0.3? We just take the number halfway in between 393 and 64? Why wouldn't you take the number halfway in between, or some, just interpolate? Was that what you would do? Huh? That's not good, because that wouldn't be the right way to do it, because remember the curve is not a linear curve, it's curvilinear. And so if you were just to try to do straight interpolation, you're gonna be off. So this article is a good Well, when the article was written in 1992, well, we had a lot of PCs in 1992. So I'm even not, but it is what it is. It's useful if we didn't have an easier way to do it, e.g. G-Power. This would be a decent option. But there are easier ways and more accurate ways to do it, as we'll see. So that's, we're going to do a couple more. So we're going to do, we did independent, we did 1, we're going to do 2, and we're going to do 7 and 8, okay? So we're going to do 2, which is the significance of Pearson's correlation coefficient, right? So I'm looking at table 1 again. And the effect size is simply R, 0.1, 0.3, 0.5. Does that, those numbers look familiar? Where did we get those? Where did we see those numbers earlier? 0.1, 0.3, 0.5?
Square root.
Square.
Yeah, that's the square root of 0.01, 0.09, and 0.25, right? So it's small, medium, and large. And then we would, of course, use row 2, significance R. Determine what alpha level you want. And then based on small, medium, or large, determine your sample size. And in a lot of cases where we just don't have a good estimate of what the sample size is, sometimes the best you can do is like Aaron said earlier, I'm just going to do small. Or I think it's going to be medium, and you might have some rationale for that. And if that's sort of the way you're working, which in a lot of cases that's the way we have to work, because there just might not be better evidence out there, then this will give you exactly what you'd get if you use G-Power or some more sophisticated tool to calculate your sample size. If the best you can do is, well, I think it's going to be small, or I think it's going to be medium. And if you're going to make an error, which way would you want to make the error, Aaron? Between small and medium, you would want to err on what side?
The small.
Yeah, you would want to err on the side of having great. Waste your resources on that side and find a significant result. At least have the power to find it, as opposed to having to throw the whole thing in the trash can because you don't find any significant results and nobody wants to publish it. Jerry, you have your hand up.
I had a question. Is this going to work as far as, I've done a couple of studies that are content analysis studies, and we've gone in, we've run the numbers, and we've gone, yeah, it looks good, but, if we would add 10 more, add 10 more to N in each category, then it'll maybe give us more power. Therefore, can I use this with that kind of a study as well as,
You should, and that would be a better way to do it than the way that you just explained.
yeah.
But you're not the only person. I've worked with a lot of people, and I think every person I've ever worked with would have done, exactly the same thing. So it's not. But as long as you're doing, for our 2 examples, you could be doing paired, or you could be doing independent sample t-test with 2 different content analytic groups of whatever. I don't know what it is that you're analyzing, but that, and if you're doing that, you can use this. Or if you're doing an R, you can, as long as it's a test that's covered here, it makes no difference whether it's artifacts or the unit of analysis is an individual. It makes no difference in both cases. The power would work exactly the same. Does it make sense?
Yes.
So we have the R. Did we? We didn't work the example. So his example for 2, for a significance test of sample R at alpha is 0.01, when the population R is large, a sample size of 41 is required, right? Everybody can get that 41? Yes?
0.01 you said?
Yes. And so the sample size would be 41 total, right? There's no per group here. This would be total sample size of 41. Good? Questions? Somebody nod their head north and south. That it's making sense. Thank you. One-way analysis 7. One-way analysis of variance. So ANOVA. One-way meaning what? When we say one-way ANOVA, we could also say what? Huh?
Directional hypothesis.
No, it could be directional or non-directional. One-way means what? Explain that to your mother, huh? That's correct. One independent variable, how many groups? Right. Could be 2 or more groups, right? If you just had 2 groups, you'd probably do t-test. 2, 3 groups, you probably. So one way with 2 groups, you probably would do a t-test. One way with 3 or more groups, you definitely would do it. So one way means one independent variable, right? 2-way, right? 2 independent variables. So we're doing just one independent variable. It gets much more complicated to calculate power when you do 2 or 3-way ANOVA. One-way clearly is pretty straightforward. So the effect size for on table 1, one-way analysis of variance, is that an F? I always sort of struggle. Is that an F? Is that a Greek letter or what is that? Huh?
It looks like an F to me.
But it's a funny looking F, isn't it? It's not the same F that he uses in the text of the document. I'm just going to call it F.
It's more like fortissimo.
Huh?
It's more like the fortissimo F's in music.
I'm going to just go with F if that's okay with you. So we're going to call that F, and I think that's probably, but it's not the F as in the F test. It's a different F than the F test. That's why it's sort of I might be confused. It's not the same F as in the F test. And so we calculate this F by the effect size index is the standard deviation of the group population means divided by the common within population standard deviation. That's kind of a mouthful, isn't it? So the effect size index is the standard deviation of the group population means divided by the population or the pooled standard deviation. So I'll show you that calculation, or you can flip a couple pages ahead in your notes and you see the calculation. The calculation is, it's 8th grade or maybe 6th grade math. It's not very, it's just once you see it, you say, oh, okay, I got it. And so if you don't get it now, you're good. When we look at it in detail, you'll know exactly how to make that calculation. And so that's how we calculate F. It's just 2 different standard deviations that it's the ratio of. And then we have small, medium, and large, 0.1, 0.25, and 0.4. And then we'd use row 7 on table 2. And it'd be based on the number of groups that we have in our ANOVA, right? We have 2, 3, 4, 5, 6, or 7. And we can see that 2 groups is the same as the mean difference, the number 1, right? So 2 groups is the same as the mean difference or row number 1. And that would make sense. I would be disappointed in Cohen if that wasn't true, but that is true. And so depending on your group size, the number of groups you have, you would just then select your alpha and then you'd work across the table. And so he's got kind of a convoluted example. So some psychologist considers alternate plans involving comparison of means of either 3 or 4 groups, both of which she believes that the effect size will be medium. She finds that alpha of 0.05, the necessary sample size per group is 52 cases for 3 groups, and if she does the 52 cases for the 3-group plan and 45 cases for the 4-group plan, thus a sample size of 156 and 180 is needed if F is equal to 0.25. Does that make, can you work across that and come up with those same numbers? Yes? So it's just multiplying the number times 3 or the number times 4 to get the total sample size that you need. Everybody's good at that? Questions on number 7? Somebody say no. No questions? Okay. So now we're going to do number 8, which is multiple regression. And so in this case, it looks like it's still the f, but then in this case, it's f squared. This one's easy to calculate. It's just r squared divided by 1 minus r squared. 0.20, 0.15, and 0.35 would be small, medium, and large. Effect sizes. And so you would take your estimated r squared and divide it by 1 minus r squared, and then you would place that on that small, medium, and large continuum. And then you would use the rows that start with number 8 on table 2, and the number k is the number of independent variables that you're going to have in your analysis. And he gives the output for between 2 and 8 independent variables. And take a minute to read example 8 that he has on the bottom of page 158 to see if you come up with the same sample size. And note that it's alpha 0.01 that he's using, not 0.05. Everybody get it? Match what he had in his example. Good enough? Okay, so now same examples, but let's do it with G power. And because of the resolution of this screen, I can't see the bottom part. And so what I think will work if I do window, hide distribution. So, I mean, these graphs are like all graphs. I mean, it's not a lookup table, but they sort of graphically represent, but you can't use it as a lookup table, but it's okay, but I'm just going to hide it so we can see the entire dialog box. And then we'll just work through those couple of examples. And then you can do the examples that are on the next slide that you have in your handout for today. You can do those with both the Cohen article, and you can see how that compares to using G-Power. So the first Cohen example, so I'm on page 158 again. And this is D is equal to 0.5, alpha is equal to 0.05. And that's all we need. So in this case, it's t-test. And so we have exact, which we'll use. We have f, which we'll use, and we have t-test, which we'll use. In this class, I won't have you use chi-square or z-test. And so we're going to do t-test. And in this t-test, it is mean difference to dependent groups or independent groups. And so 2 independent groups. And are we going to do a priori? We're going to do a priori. You could, if so inclined, try some of the others. Two-tailed, always. D is 0.5. Right, so that's correct. Effect size D is example says 0.5, right? 0.05 for alpha. 0.8 is what we want here, right? And the ratio, in other words, are the two groups n equal? And so the ratio is going to be 1. And that's the assumption. He says it throughout all of his examples, is that the two groups have exactly the same number of participants or the same number of observations whether you're using individuals or some social artifact. And if I calculate this, what should I get for the n? What should I get for the n?
Number.
Huh?
Size, sample size.
Yeah, but what should that number be? What should it be? 64 per group or total? So 128, yeah, and 64 per group. Makes sense? Easy enough? Yes? Is it like, everybody good? Huh? Questions? The next problem, so problem 2 is the R. So it's just a correlation. Our test that we want to calculate power for is just a correlation coefficient. And there's actually, you could do it, well, the right place to do it is this point biserial model means one of your variables is just a dichotomy, so 1 or 0, and the other variable is a continuous variable. I'm assuming that's not the example here, but that's what the point biserial model is. So one of the variables is just a dichotomy. I don't think that's, then there's not much difference if you were to choose that one. The n would just be off by a couple. I think the test that we should do to come up with at least the number closest to what he has here is under the exact test, and it's correlation bivariate normal model. And I know that because I read the help for G-Power, okay? If I hadn't had read the help for G-Power, I might have tried the point biserial, and I would have been okay because the n is just off by a couple anyway, and these are just estimates. But I know it's a change they made in from the earlier version, and so I read that. And so, what is it? We're doing two-tailed, right? And the correlation coefficient, the hypothesized value is what? Large, right? Which is what? 0.5 and 0.5. 0.5, and alpha is 0.05, and power is going to be 0.8, and this would be, we're normally comparing to 0, right? So is our correlation coefficient significantly different than 0? But sometimes you might be interested in comparing it to some number other than 0, and that's what you could do here. But we're comparing it to 0. What n should I come up with? What is that? What n should I come up with? What is it?
28.
Yeah, 28 at alpha at 0.05.
I get 29. Is that close enough for? Huh? You got 29? Where did we get 28 at?
28 from the Cohen.
Oh, 28 from the Cohen article. 29 here. If somebody wants to quibble over, go ahead. It's just not worth it, right? It's because they're just estimates, right? And is 28 going to be or 29 going to be exactly the number we need? No, but it's just an estimate. Okay, so far so good. All right, so then we're going to just do these other two. 7 is the ANOVA, right? And so ANOVA, what kind of test do we do with ANOVA? F-test, yeah. And so F-test, and then we have all of these things. And we want to do ANOVA omnibus one way. And the omnibus is the overall test, not the group differences. It's just the omnibus F-test. And we're going to do a priori. And our effect size F is what? And if you mouse over that, if you ever forget the small, medium, and large, which they match up with the Cohen article, and a useful thing to do, you just don't really have any, you think it's going to be small, just mouse over it and it will give you those numbers. So what did he say it's going to be? 0.5?
2.25.
D is equal to 0.25. Alpha is 0.5. This is 0.8, yeah? Is alpha 0.05 or is it?
It's 0.0.
And then the number of groups is, for the first example,
3.
and n should be 159.
156 is what this says.
Should we lose sleep over 3 people? I wouldn't, but if you wanted to, that would be entire. But it's I'm not exactly sure why the estimates, but it's close enough for any research that I've ever been involved in. Okay, and then the other example was 4 groups, right? And what should the number be there, Jerry?
180.
I feel better. It's exactly 180. All right. And then the final example is multiple regression, yeah? And so it's also F-test. And it's going to be under linear multiple regression fixed model, R-squared deviation from 0. So the null hypothesis is that the R-squared doesn't vary significantly from 0. And that's what this tests. This one would just be some number other than 0 for the null hypothesis. And in every case I've ever been involved in, we always using 0.
If you were to do that second one, do you have to set what the number is that's different from 0?
Yes, and so it might be 0.1 or 0.6, or it wouldn't be 0.6 probably, but it could be some small number. So you're so confident in your hypothesis that you're not going to say it's from 0, you're going to say it's from some other number. In most cases, it's in a hierarchical model, and so we're adding blocks, and that's where you'd really probably use that, which we'll talk about as we talk about regression. So the F squared, which clearly is an F there, isn't it, is what?
0.15.
0.05, 0.8.
They have the alpha of 0.01.
Oh, yeah. I think that's will matter. Yeah. How many predictors?
8.
148. What did they get?
147.
Good enough? Okay. Questions? Work those 4 problems. Do the first 3 in Cohen's article, and then do the first 3 with G-power, and then we'll look at the 4th one here in a little bit, okay? And when you're using the Cohen article, try to guess what you think the n should be. If it's not exactly small, medium, or large, it's in between the two. Make an estimate as to what, and then compare it with the G-power estimate just for kicks. Just about done? No? If you don't have a laptop, maybe you can work with somebody else that does, just so you can get the exact number, or you can get the estimate from G-Power. So if you got those 3 done, you can try doing the 4th one in G-Power. Or you could flip the page and see how I hand calculated it and sort of square that with the sentence that we read twice from how Cohen defined it. You got them? Couple more minutes to finish up? So for the first problem, when you use the Cohen article, what's the approximate n that you came up with? Or and does the r square of 0.2 fall right on a medium, small, medium, or large? What is 0.2 minus, or 0.2 divided by 0.8 is what? So we had to calculate to do the Cohen article, we had to convert this to an f squared, right? Which is 0.2 divided by 0.8, yeah? Which is what? 0.25. And is that small, medium, or large?
Medium-ish.
Medium-ish. And if it's medium-ish and the number of independent variables is 7, the n would be, what do you get for the n? 102?
You should just always go lower.
So what would you say? We should go with 770 or 726? Because we came up with, let me see, I gotta flip the page once. We came up with 0.25, yeah? 0.25 is in between medium and large. I was thinking it's between small and medium. It's in between medium and large. And so in between medium and large, would you go 102 or 48?
I don't know 48, but
So you would go with the lower
that's
number?
what I was saying. You should always just go small, probably. Right? That's what you were saying. That like you should go with a larger sample size.
Yes.
Even if it's directly in the middle.
That would be a safer bet. You might be misplacing resources because you're collecting a larger sample than you need. But that's probably a better bet than not collecting enough and ending up having to A, either collect more, or B, just throwing your stuff in the garbage because you can't find anything. So 102, if you use G power, what number do you come up with?
80.
What is it?
80.
80. Which, you did 102, you did 80. I think that's probably good enough probably for most research that I've seen. So that's 1. 2 is what is the total N needed for a group of nova where power is 0.8 and the effect size is large? That's an easier one to do, right? The sample size total would be what? Brianna, what do you get?
Wouldn't it be 18 times 4?
And you come up with 18 because it's medium, or did I say large? It's large, and it's 0.05. And how many groups? I come up with 18 times 4, yeah. Would be the total sample size. And does that square with what you get when you use G-power? Or pretty close? Okay, so it makes sense? And then the third one, you anticipate an R of 0.2, and you want alpha 3.05 and power to be 0.8. What is the approximate N needed for this t-test of significance of a product moment correlation? 0.2, is that small, medium, or large?
In between small and medium?
Right in between the two, right? So potentially you could extrapolate and just take the N right in between, but you know that that would probably not be the wisest choice. You'd probably be better doing, as Elena said, and just taking the small, or the going with the larger or smaller effect size and getting a larger N consequently. Okay? So what do you get when you do, what was your estimate of what you need for sample size? Khalif, what did you come up with for number 3?
I'm lost.
You're lost?
Yeah,
Like lost
lost the movie.
total? You didn't come up with anything? So let's, we have a minute to sort of step back and just try to find our way. So the R is 0.2, yes. And then we have those other two. We have those other two things that are fairly constant, 0.05 and 0.8. And so the first thing I would do is look on table 1. And on table 1, if we look at significance of product moment R, which is the number 2, and the small is 0.1, the medium is 0.3, and the large is 0.5. You see that? And so 0.2 is right in the middle between small and medium, right? And so keeping that in mind, we flip the page and look at row number 2 on table number 2. And we're looking at the 3 columns under alpha is 0.05. And small would be 783. Medium would be 85, right? Did I get that right? So I guess Elena's going with 783. And that could be that extreme, right? So if you did it make sense? And so, I mean, you could, if you wanted to, just take, the middle point between 783 and 85. That would be a bad bet because we know that the power curve is not linear. It's non-linear, and you can't just do that type of linear extrapolation. And so, this article, I wouldn't say useless, but not very useful, and may steer you in the wrong direction if you were to try to do this problem with that. What do you come up with when you use G-power? Those of you that...
128.
And so that's a big difference between that.
You so did it wrong.
I must have done it wrong.
What did you come up with?
193.
How many? 128. What did you come up with?
I must have done it wrong.
Everybody else got 193. You must have did it wrong. All right, we're good. Khalif.
Yes.
So I mean it's really important. We're just talking about this today. You're gonna have to do these kinds of problems in a couple weeks. You're gonna have to do these kinds of problems on the exam, and you just have to be able to do it both with the book and with PC. And so you'll have to get G-power on a computer in Gaylord or your computer and work these same problems with your PC, and then when we visit, I'm happy to help. And that would always be the case. So when you come visit me, if you have questions, we need to be sure to get those questions answered, okay? So far, so good?
I have a question. If it was like, so it's somewhere between 783 and 85 there, and the answer was, when we did on here, 193.
Yeah.
Like, if we put 783 as the answer, but maybe it's really 193, which is closer to 85.
So are you talking about like an exam test or
Well,
something?
like, if we had to do this and calculate it, and, well, I guess we wouldn't have both options.
I wouldn't try to trick it. I wouldn't be trying to. This is all about if you're going to do research. How many people do you need, right? I'm not interested in tricking anybody with a question.
Just pick the smaller number, always if it's between.
And I wouldn't give you one like number 3 and tell you to do it with the book. It just isn't fair because it just, my guess is probably as accurate or inaccurate as yours. And so number 3 would be one where you'd use G-Power, come up with a number and give me that number. You'd get one like maybe number 2 with the book, yeah? And I give you the couple pages from the article and on the in-class exam with a problem like number 2 and tell you to give me the power. And I think that's fair because it's right square with one of the effect sizes, medium. Make sense? All right? Anybody try 4?
I worked through it by looking at your notes.
And so let's,
I'm confused with where you got 5.67, but then I was like, oh, it's the sum of.
so let's look at the kind of convoluted sentence on, so this is on page 157, at least it's one, my page has got 2 different numbers on it. But I'm on page 157, I think that's the article page number. And under number 7, the one sentence is the effect size index is the standard deviation of the group population means divided by the pooled common population standard deviation. And so the standard deviation for the first part of that, the standard deviation of the G population means would be that calculation where I took the mean, which is, remember the formula for standard deviation is what? It's each score minus the mean squared. What happens if we don't square them? It will always sum to 0, right? And so you always have to square them to get around that problem of them summing to 0. And there I have the formula for you right there. And so I come up with 0.667, and I'm dividing that by 3. Usually degrees of freedom are what for standard deviation? N minus 1, but this is the population standard deviation, not this. So sample size population, degrees of freedom is equal to N minus 1. Population standard deviation, degrees of freedom is equal to N. And so it's the difference between population and sample. And we'll talk about degrees of freedom and what the heck that means as we move forward in the coming weeks. And I come up with 0.471. And then I divide 0.471 by the standard deviation, which would be the standard deviation that we would calculate if we put all of these people into one group and calculated the standard deviation for that group. Okay? And that's what the pooled standard deviation is. And again, the assumption of this test, this ANOVA, would be that there's not a significant difference between the 3 standard deviations. So essentially we can take any of the 3 and it should be pretty close to this. That's an assumption of ANOVA and of t-test. And so I divided that and I came up with 0.203 for the F, and then I calculated an N somewhere between 699 and 156, about as useful as the previous calculation we did with R, right? So, okay, I need at least 966 people for my dissertation, but I might be able to get by with this view as 156. It's just not. People look at you odd if that's what you present them, but you can use G-Power, and I come up with 237. Did you come up with 237 using G-Power? So to do that problem in G-Power, this thing over here, which I can't show you because I don't have enough resolution. No, I want to see, where's the little determine thing? Yeah, this is what I want. Not that calculate. This thing right here. That little drawer comes out. And so if we're doing F-test, right? This was an ANOVA problem. F-test. ANOVA one way, omnibus, and a priori. And if we just do, let's say we don't, you don't have the calculations that I did on the previous page, we're going to use the little calculator that G-Power gives you. How many groups do we have? 3 groups, right? And our standard deviation within each group is what? 2.32, is that what I give you? And we're just going to leave these sample sizes all at 5. I hope that works. And this mean here is going to be...
I thought that you said that the 0.23 was the pooled standard deviation. Is that the same thing as within each group?
The within group, in this case, the within each group standard deviation is the same, or should be the same, as the pooled standard deviation, assuming you've met the assumptions of ANOVA.
Okay.
And this standard deviation, the standard deviation that we calculated on the previous page is not pooled or unpooled. It's just a calculation that has to be done for this power analysis, okay? So the within group should be the same, or at least not significantly different. And remember, if you ever studied ANOVA before, we do Levene's test. Does that sort of ring a bell? We do Levene's test to test the standard deviation, and assuming that we fail to reject the null, then our standard deviations are not significantly different. So hopefully that makes, so these 3 numbers here should be what, 5, 6, and 5, or 6, 5, and
6, 5, 6.
so 6, 5, and so this is just a easier, and I mean, my guess is, are you ever going to know these numbers? If you're calculating power for your dissertation, you're probably not going to have these numbers. Did I say 6 or should be 6? You probably won't have these numbers. What you're going to have is some intuition about this should be small, or this should be medium, or this should be large, and that makes this problem really easy, right? Then you can just mouse over the small, medium, or large and put that sample size in, and you'll be good. But now I should be able to say calculate, and I get effect size of 0.203. Is that the same as I got on the previous page? I'm sorry, when I calculated F, I got 0.203, which is the same thing I have here. I'm going to tell it to transfer it to the main window, and I'm going to then calculate, and we get 237, which matches the, well, it's in between the 2 numbers that I give you, 966 and 156, but it's also the same thing I said that I got with G-Power. Questions? Confusion? Frustrations?
I just had a question on the number 3, that t-test.
3 from the, yep. So this is a t-test for Pearson's correlation coefficient.
Yeah. So on the G-Power,
Yeah.
so you go to t-test.
No.
No.
Where do you go?
Is that,
Yeah, exact.
oh,
So when you did it under t-test, what did you get for n, Michael?
128 or something.
That's a bigger difference than I've seen. In the past, it's been whether you do the exact test or do it here. The difference is sort of like who really cares because it's 4 or 5, total n of 4 or 5. But anyway, you should try it under exact tests and then the correlation. And remember, you have to put down the 0.2 and for the hypothesized. And the hypothesized correlation would be 0. And you should come up with 193. Other questions?
So you, wait, I just want
Yeah, good,
to go
good.
back here. So I go to correlation bivariate normal modal. Is that right? Model.
Yep.
And then two tails. The hypothesized.
And so the first, is that Greek letter rho, I think? And so for the first row, you would put in 0.2. And then the bottom, the last number should be 0 because we're comparing it to 0.
Okay, I got
Get it?
Yep.
Good, good.
Thank you.
All right. If there are no questions, I'll see you. I'll put the 2 videos up if you care sometime in the next couple of days. I will post the notes. I'll try to get it done. Well, it'll be done by Monday morning at the latest. This last week I got them up there on Friday, but just check Monday morning. They'll be there. And so get the notes for, you have to read 2 chapters, but focus on the chapter on something about cleaning up your mess. I think it's chapter 3 on cleaning up your data. And the title of the chapter is something about mess, isn't it? Cleaning up your act. So focus on that chapter. The chapter 3 is useful, but focus on because we're going to really work a lot with chapter 4, and we're going to try to clean up our act. All right. So I'll see you 2 weeks from tonight.